Okay, today we're talking about reflections of geometric figures on the coordinate plane. They ask us to look at the two triangles shown on the coordinate plane. So we have triangle 1 and triangle 2. It says describe the positions of the two triangles on the plane. Well, we can see that triangle 1 is in quadrant 1 and triangle 2 is in quadrant 2. So they're on opposite sides of the y-axis. And I'm going to go ahead and mark the y-axis for us so that we don't forget which one is the y-axis. Whenever we work with reflections, I think it always helps to mark the axis that you're going to be flipping it over. So make sure you do that. So we know they are on opposite sides of the y-axis. We've already said one's in quadrant 1 and one's in quadrant 2. Sorry if I'm kind of messy. And they seem to be turned. They seem to be facing opposite directions. That's a good way to put it. We'll say they're facing opposite directions. Now it tells you to use your patty paper. If you don't have patty paper, stop my video and go get some. With your patty paper, trace figure 1 and the x and y axis. So you'll have a big plus sign with the first triangle traced. And it says to flip your patty paper onto its backside over the y-axis and describe what you see. So do that right now. And hopefully you'll see that when you flip it, when flipped, triangle 1 lays on top of 2 perfectly. They are a perfect match. Earlier when it says, do you think they're congruent? Hopefully you know now they are congruent. It's a perfect match. But we're going to check one more thing. It says on a new spot on your patty paper, this time trace figure 2 and the axis. So you're going to have another plus sign for your coordinate axes. Trace triangle 2, flip it over onto its backside over the y-axis and describe what you see. Well, hopefully you see that when we flip triangle 2, it lays on top of triangle 1. And it is a perfect match. Which tells me the two triangles are congruent. So let's make a little note. They are congruent, and you'll hear me say this a lot. Congruent means they are the same shape, same size. Here we have some more explanation. Figures that are mirror images, that's a good way to describe it. When I said they were facing opposite directions, it's a reflection. It's a mirror image. And that's why we call them reflections. A reflection is our third transformation. It's the transformation that flips a figure across a reflection line. And this is important. A reflection line is a line that acts as a mirror. So that corresponding points, we're going to practice this in a minute, are the same distance from the mirror. In this coordinate plane, either triangle is a reflection of the other. That's why we had you trace with the patty paper twice. What do you think is the reflection line in the diagram shown? Well, hopefully you see I've already highlighted it. The reflection line is the y-axis. For this picture, the reflection line is the y-axis. On the coordinate grid above, draw the reflection of each triangle across the x-axis. So I'm going to highlight the x-axis this time. Don't forget the x-axis is the horizontal axis. And we are going to draw a reflection, okay, across the x-axis to see if it's going to work. What we're going to do is take triangle 1 and we're going to count. Triangle 1, the first vertex is 2 spaces above the x-axis. When we reflect it, it will be 2 spaces across the axis. So I'm going to continue down, and there's 2 spaces, so that would be my first corner, or my first vertex. I'm going to go to this one, and I'm going to count. It was 2 above, so now it's 2 below. And I'm going to connect it, so now this is the bottom of my triangle. Then I'm going to go to the third one, this top vertex, and I'm going to count. It is 1, 2, 3, 4 places above the axis. So I'm going to go 1, 2, 3, 4 below, and I'm going to connect. And there's my triangle. And you can see it has been flipped. It's upside down. Let's do the same thing on the next one. Triangle 2, I'm going to start out here. On the far corner, 1, 2 above, it should be 1, 2 below. I'm going to go to the one next to the y-axis right here, and it's going to be 1, 2 above. Now it needs to be 2 below. And I'm going to connect those. That's the base of my triangle. Then I'm going to go to the very tip top of my triangle, and it is 1, 2, 3, 4 above. And now I need to be 1, 2, 3, 4 below. And when I connect those, hopefully you can see I have a reflection of 1 here and a reflection of 2 there. So they too are mirror images. Reflections are kind of cool. We get to flip them over a reflection line. And for our situations, our reflection lines will always either be the y-axis or, as we did down here, the x-axis. Okay, let's continue on the back. It says reflect parallelogram ABCD using the y-axis as a reflection line to form parallelogram A prime, B prime, C prime, D prime. So let's go ahead and mark our line of reflection. It's the y-axis. Please mark it on your paper. And let's get to work. It says list the ordered pairs for the vertices of the original parallelogram and the reflected image and tell how far each point is from the y-axis. Well, we have A is at x is -4 and y is 1. So we'll say -4 and 1. And if you count, A is 1, 2, 3, 4 units from the y-axis. B, we have the ordered pair -2, +2, and it is 2 units away. C, down here, C is at -2, -3, and if we count, it is 1, 2 units away from the y-axis. And D is over here, right there, at -4, -4. And it is 1, 2, 3, 4 units away. Okay, let's flip this shape over. If you have patty paper, you can go ahead and trace it and flip it. I'm just going to flip it and draw it the way I think it should be drawn. I know that B is 2 units away from the y-axis, so I'm going to put B prime 1, 2 units away. So there's my B prime. A was 4 units away, so I'm going to pick 1, 2, 3, 4. And A prime will be 4 units away. If you look, they have the same y values, but the x values have changed. So I'm going to start with C. It's 2 units away on this side. It needs to be 2 units away over here. and that would give me C prime. D is 4 units away on this side. It needs to be 1, 2, 3, 4 units away over here. And there's my D prime. And when I connect them, I have a parallelogram that I think looks congruent. You can use your patty paper and check to make sure. It is a mirror image of the original parallelogram. My ordered pair for A prime is now 4, 1, and it's 4 units away. B prime, X has a value of 2. My Y value is 2, and it's 2 units away. C prime, down here at the bottom, C prime is at 2, -3, and it is 2 units away from the axis. And then D prime is at X is 4, Y is -4, and it's 4 units away. Then it asks us to do this. Look at the list of ordered pairs for the parallelograms. How do the coordinates of the image compare to the coordinates of the original? After reflection across the y-axis, describe any pattern that you see. Well, with A, we had a -4, 1 for my ordered pair. A prime became +4, 1. B was -2, 2. Well, B prime is +2, 2. C was -2, -3. C prime was +2, -3. D was -4, -4. D prime was +4, -4. Well, when we look through these, we can see that for every one, the y coordinates stayed the same, but the x coordinate, the sign changed. We went from -4 to +4, -2 to +2, -2 to 2, and -4 to 4. So we can see there is a pattern. The x's were the opposite sign. So we can say opposite of x, but the same y. And that's the pattern that we would use. Okay, let's see if the same holds true for the next picture. They want us to do the same thing. So I want you to pause my video and reflect the picture. I would be counting. I would count to see how far each vertices is from the axis. And I want you to pay very close attention. This time, they want us to use the x-axis. So go ahead and before I turn you loose, highlight your x-axis because the x-axis is the one that we're going to use for our reflection. So pause my video, go do all this work, and then come back and check your answer. Okay, hopefully you did a good job on this. And you have all your ordered pairs listed, and it said, how do the coordinates of the image compare to the coordinates of the original parallelogram after the reflection over the x-axis? Describe a pattern you see. I would have to say that it looks like all of the x's stayed the same. So this time, x's stayed the same. So I'm going to say same x, and we took the opposite of y. You can see we had a -1 for y, then we had a +1. We had a 4, but then we had a -4. 2, then a -2. -3, then a +3. So each time we had the same x and an opposite y. All right, number 4. Let's try one without a graph. So we have to remember the rules. A triangle has vertices ABC as shown. If this triangle is reflected across the x-axis, what would the ordered pairs of the reflection's vertices be? Well, we just did an x-axis. For the x-axis, the rule is same x, opposite y. So let's do this. A was -4, 3. If I keep the x, I still have -4. I have to take the opposite y. 3 becomes -3. For b prime, keep x. X was 1. Y is 5. Let's take the opposite of 5. That would be negative 5. And then c prime, x was 2. Let's keep it. Opposite of negative 2 is a positive 2. It's very important that you realize that when we take the opposite, we change the sign. Do b, this time we're going to go across the y-axis. If you go back up to the top, for the y-axis, we do opposite x. Same y. Pause my video and give me your new points, and then come back and check. All right, let's see how you did. When we go across the y-axis, we take the opposite of the x-coordinate, and we keep the y-coordinate the same. So these were our original values. A prime, opposite of a negative 4 is a positive 4. Keep the 3. For b prime, opposite of 1 is negative 1. Keep that 5. C prime, opposite of 2 is negative 2. Keep that y-coordinate. Hopefully this makes sense. The more practice we get, the better we're going to be.